Hello, welcome. Um, I'm not with Jevity any longer. Jevity got bought by Accenture, and then I went off and joined a bunch of my friends, and we now have our own independent consulting company that lets me continue to do all the things that I've loved to do for many years, which is stick my fingers into as many HL7 and standards and fire-related pies as I can. So I've been heavily involved in the standards community in Canada, although more involved internationally in the last 10-ish years. But I've been playing in the standards space for a long time, and hopefully I can share some useful things with you. Feel free to interrupt me at any point and ask questions. They can be related questions or not. I'm happy to chase whatever rabbits down whatever holes you wish. So long as it's of interest to you, I'm happy to chat. This deck is licensed under Creative Commons. It contains content contributed by a wide number of folks within the FHIR community over many years. So I'm going to say thank you to all those folks. And so long as you include the slide, you are welcome to use this deck. Don't know if I included a link to it, but if you reach out to me on chat.fire.org, which I'll talk to you a little bit about further on in the presentation, I'm happy to share the source material with you if that's of interest. All right, so well, before we get into the what is FHIR, let's talk about the why of FHIR. FHIR came into being 12-ish years ago now, maybe approaching 13. And it came into being after we'd had version 3, which is an HL7 standard that we invested in very heavily in the Canadian space. Version 3 had been around for about 10 years, and we were not getting what we had hoped for out of it. Specifically, we had objective of interoperability is, of course, breaking down silos between systems and having information flow freely. And that wasn't occurring. We had a number of version 3 based implementations in a variety of Canadian jurisdictions, but they were all slightly different and couldn't talk to each other. And vendors couldn't use one solution to work with all of the others, which made them unhappy. And we had version 3 being implemented in the UK, in the Netherlands, a little bit in a few places in the US, lots in Canada, and none of those systems could talk to each other either. And we could spend a bunch of time talking about the whys of that, but it doesn't really matter. But we weren't getting the interoperability that we hoped for. And we had a session at one of the H7 meetings where we talked about what the challenges were with version 3. And so it was evident that there was an appetite for something newer, something better. And so Graham Grieve went away and brought back this thing that he initially called Resources for Health, which we rebranded as FHIR because it was an acronym that didn't have a whole lot of hits on the internet, and that we could trademark. It was one of the first names of things that HL7 actually paid any attention to when we created it. And FHIR was born. But if we want to look at the underlying purpose for FHIR, with interoperability, we're trying to increase what is labeled here on the diagram as semantic depth along the x-axis. But I think of it as how computable is the data. And we start out with text, which is not terribly computable at all. Obviously, you can use natural language processing on text, but when you're doing that, you're really transforming the text into something else that is more computable. And so we want data to be computable because we want to be able to search against it. We want to run decision support against it. We want to find the relevant information at the time that a decision needs to be made, so that we make the best choice, the most informed choice that we can, whether it's delivering patient care, administering the healthcare system, making decisions about public health, whatever it might be. And we've had lots of different standards over the decades that have worked on increasing semantic depth. In the HL7 space, we started with HL7 version 2, and then we had CDA, and then we had version 3. And there are other standards out there for sharing data, some of them not necessarily healthcare specific. But one of the things that we were noticing in our trends is that while we were successfully increasing how computable the information was, we were also significantly increasing the difficulty of implementing systems in general, and also implementing systems that successfully interoperated. And that was not super useful. So the driving question when we were looking at FHIR in the early days was, can we continue to increase or at least sustain the relatively high levels of computability that we had achieved with previous standards, but make it easier? Because it turns out that if you have a really capable standard that is really hard to implement, it doesn't get implemented very much, and you don't actually get any real interoperability, and you don't have value. So what we wanted is something that delivered value, but was easy, so that there was a chance of that value actually manifesting. And so we set out and we defined sort of a manifesto of what we were trying to accomplish with FHIR. And we had 6 main objectives. We wanted to be focused on implementers. We wanted to target the common stuff rather than chasing edge cases, because we were really good at that. We wanted to leverage web technology because that seemed like it was a pretty robust stack and was having lots of success elsewhere. We wanted to support human readability. We wanted to support a range of paradigms and architectures, and the specification itself needed to be open. And all of those were shifts from where we had come. So what do we mean by implementer focus? In the version 3 days, and I can say this because I was one of them, I was heavily involved in version 3, we were focused on data models and elegant data models and comprehensive data models that could model absolutely everything. It was beautiful, and my brain still thinks in version 3 in some ways. But what we ended up with was specifications that were really abstract, and when you put them in front of your average implementer, they went, what's that? And what do I do with it? We had lost touch with what should have been our primary audience, because successful interoperability in healthcare is not met by making the data modelers super happy. It's met by making the people who actually have to write code that causes data to flow from one system to another system happy, because they're the ones who actually have to make this work. And so we did a few things. First of all, we went from having 2 or 3 pages of text sometimes to define our elements to having, first of all, labels that were intuitive to the readers, then short descriptions that conveyed a little bit more than that, but were not more than a sentence, and then more in-depth definitions that were sometimes a short paragraph, and occasionally we might have rationale or a little bit about modeling approach, but all of that was you drill through to it if you need it, and often you didn't, which made it much more attractive to software developers who really don't like to read anything if they don't have to. And I can say that too, because I'm one of them. Second thing is we wanted to make the resources, the data structures that represented the data, as simple as possible to understand. And rather than saying, here's a wonderful paper specification, go forth and build it, we said, well, no, we're actually going to build it too. So we'll show you what it looks like in code to actually have a system that knows how to write and consume this data. And furthermore, we'll have more than one of them, and we will test and make sure that they can actually talk to each other, because we also had a history of writing specifications that seemed really good in theory, and passing them and balloting them and declaring them normative locked in stone without ever having people write software to use them. And then somebody comes along and writes the software and discovers that, oh, well, that's great, but this part here doesn't work. And we went, oh, cool. So the reference implementation approach meant that we had the specification tested in the real world in terms of its ability to actually share between different systems, and for multiple independent software developers to look at it, read it, write code, and share information and see if they actually interpreted things the same way, whether we had covered all of the loopholes, whether we had written things in ways that were clear and unambiguous. And of course, there was a fair bit of iteration in that. And finally, we had lots and lots of examples and tooling that forced them to be valid before we could publish. In fact, we couldn't publish a new data structure without having an example of it. The tooling that we used to do our publication would just blow up and die because having examples is a really important thing for software developers. It is a common thing to take an existing example and start with that as you are crafting what you want your instance to look like, rather than just looking at the spec. Second thing is, it says here, support the 80%. And HL7, the FHIR community, has a rule that we call the 80% rule. And this is sometimes misinterpreted by people, so listen closely to this. The notion behind it is that we don't want to cover every single edge case, because we tried to do that with version 3, and we were somewhat successful. You could cover pretty much anything you wanted to with version 3, but it came with a cost, and the cost was that the model was really, really abstract. And that meant that you could actually say the same thing in a whole bunch of different ways. And of course, if you can say things in multiple ways, it is inevitable that the implementer community will do so, and then you can't talk to each other. So we said that we're only going to focus and include in the core specification those things that we believe that most implementations, so roughly 80%, that's where the 80% in the 80% rule comes from, are going to actually support that data element. That doesn't mean that we can't support other things. We defined a whole extensibility mechanism, recognizing that there are different things in the world that different folks need to be able to handle. But if most of the world doesn't have to handle them, then they won't be present in the core spec. So examples of that: in the Netherlands, they have an address part for houseboat across the street from. And if you have had the pleasure of being in Amsterdam, which I have a few times for Dev Days, which is a FHIR conference, you will see that that's actually a really important address part for them. I'm from Alberta, and it's not an important address part for us. And so that would fall outside the 80%. It's something that is needed in certain circumstances, but it is not needed in all circumstances. In Saudi Arabia, they actually use a secondary calendar. And they capture things like birth date in that secondary calendar, and they need to be able to capture that. Hijri date matters there. It does not matter in many other countries. And so again, that would fall into the 80%. Here in Canada, if we're interested in tribal affiliation or things like that, which can sometimes be important to some of our systems, again, important to us, but if you are in the Netherlands, or if you are in Japan or other places, it's not terribly meaningful for you. And so we would not include those elements in the core specification. Instead, we have an extensibility mechanism to manage that. So let me give you an example of what the power of the 80% is. I want all of you to just think for a moment about the notion of address. If you were going to have a screen that captured address, or you were going to have a database with some columns that were to capture address, think about what that would look like. Got that in your head? This is the version 3 data type for address. And I have some level of responsibility for that because some of the data elements that are part of this come from the Canada Post address standard. And I'm pretty sure that when you were thinking about what does an address look like when I'm capturing data on a screen or in a database, this is not what you had in mind. And this is what we were giving to implementers of version 3, and this is what we still give to implementers of CDA, which is a standard that's built on top of version 3. When we apply the 80% rule, all the stuff that is in red is not part of the core specification. So we do have period, we have uses, we have line, city, state, zip. You can still send all of those other things. So if you need to be able to send a unit identifier and a unit designator as discrete separate data elements, you can do that in Fire, but you're using extensions. And what it means is that the software developers who say, how do I send address, look at just the stuff that's in black. And they go, cool, I understand all of that. I don't actually have periods on my address, but I understand what that means. And I'm fine with the fact that I don't use it. And if somebody sends it to me, I'll know what to do with it. And if you need more stuff, then you can go do some digging and find the appropriate extensions for the other more sophisticated things if you need them. So that's what the 80% rule in the Fire space does for us. In terms of web technologies, we use HTTP. So every time you're using your browser, that's the standard that's behind the scenes. But it's not only used for web interfaces. It's used for back-end communication as well. Large organizations all over the world are using it. Our data types are drawn from the XML data types defined by the W3C, as opposed to completely inventing our own. I mean, we have some layers on top of those for more complex things, but the low-level types are all defined by them. We use multiple syntaxes. Primary one is JSON. There is still a reasonable amount of XML out there, and there are some edge cases where people are using RDF for semantic web type stuff. We leveraged RESTful APIs, which is how a lot of industry communication outside of healthcare is done these days. And all of the security stack that exists on the web, we use. So when you see that little lock icon in your browser, that technology is HTTPS, and we use that when we are establishing secure communications to share healthcare data. And OAuth, when you go to a site that says, hey, would you like to log on with your Google or Facebook identity? That's the same technology that's being used, and we can use that for healthcare as well. Last thing that we were doing is we wanted Fire to be free. So in the days before Fire, if you wanted to access HL7 version 2 or CDA or the version 3 specifications, you had to be an HL7 member and pay for the privilege. And you couldn't even look at the specification to see whether you liked it or not without paying to be an HL7 member. And that was a problem because we saw as a target audience for Fire, a whole lot of people who were not members of HL7 and probably never would be. People who write apps, people who were part of underdeveloped economies who didn't necessarily have the financial wherewithal to be HL7 members. Although there are some programs to support those types of countries, the companies within them still had challenges. And a lot of the folks who had sort of walked away from HL7 and said, this V3 stuff is out to lunch. We don't want to have anything to do with you anymore. We wanted them to see our new stuff, and they weren't necessarily going to pay for their membership to come and take a look. So HL7 Fire is licensed under Creative Commons 0, which basically means totally open source. Do with it as you see fit. If you want to republish it, you can republish it. We don't care. If you want to sell it, good luck, because it's already out there for you on the web. But if all sorts of weird things happen in commerce, you can try. The only things that are have IP rights on them is the Fire name and the Fire logo. So if you want that pretty little flame in your app somewhere, you need HL7's permission. If you want to use the word fire, F-H-I-R, in the name of your product or in the name of your event or in the name of your whatever, you need to get HL7's permission. We don't charge for that. We just make sure that you're not doing something that will dilute the brand or call something else fire that isn't fire, because that would be problematic. But those are the only IP constraints that we have. Then we have paradigm agnostic. So what does that mean? What that means is that there's a bunch of different ways that we share information or can share information, not just in healthcare, but in any other sort of environment. We can do REST, we can do messaging, we can have documents, we can have services. And what we want to be able to do is have information come in one mechanism, be viewed in a different mechanism, go out in a third mechanism, and use the same data structure regardless of what our transport mechanism, what our architectural approach happens to be. And this is new. In version 2, you had a choice of messaging, or perhaps messaging. That was the only thing that you could do and the only thing that you still can do with the version 2 standard. It's not designed to do anything else. With version 3, we said, well, there's actually another kind of thing that's kind of useful, which is documents. And so we will support version 3 messaging, and we will support version 3 documents. And version 3 documents essentially became CDA. But the data structures, when you create a v3 message, and the data structure when you create a v3 document, well, they all stem from the same underlying data model, look completely different. So if you were to take one of the v3 messages to share prescriptions in Canada, and you were to take a CCDA document that contained a prescription and look at the two data structures, there's some similarities, but you cannot take an instance of one and package it into the other or vice versa. You have to completely remap all of your data. And that means that once you pick a paradigm, you're kind of stuck with it. And the reality is that there are use cases where messaging is still occasionally a good fit, although much more rare because of the possibility of the other paradigms. And there are places where documents are a really good fit. If you're doing a discharge summary, that is an organized set of information that you want to be human readable, where you want things to be read in a particular order. There's a hierarchy to it. There's sort of a table of contents, and it's for human consumption. Document is a great paradigm for that. But there are other kinds of things where it's not. If I want to go and grab your current list of allergies as of right now, I don't want a document, because the document was written by somebody 5 days ago or 5 years ago, and maybe I've got 107 different documents. I don't want to wade through all of those to find your allergies, because it's a whole lot of work. And I will end up with the fact that you are severely allergic to, or mildly allergic to, or intolerant of, or suspected allergy to amoxicillin, or apoamoxicillin, or penicillin, or Lord only knows what. And then I have to try to figure out what the real story is. Not pleasant. If I can just hit a database and say, give me the current list of allergies, that's much better. And so different use cases call for different approaches to data sharing. And with FHIR, we use the same structure regardless of mechanism. And that means it's easier to support the appropriate architecture for information sharing for a given use case. And it's easy to move the data from one to another to another. All right, so I've used this term a few times already. Let's talk about what it is. Resource think of it as a puzzle piece. It is something that is standalone. So diagnostic report, that's a thing. It has an identity. You understand what it is. We have patient. That makes sense. We have a related person, so a mom or a child or a whatever. We have a location. And we can plug those things together, point to them to establish a story. So a diagnostic report can have a subject that is the patient. The patient may have a related person who is their primary contact or is their guardian. The diagnostic report is associated with a particular location, and we can plug all of these different pieces together. Each FHIR resource is something that is intended to be shareable um, by itself. So I can pass around just a patient instance. I can pass around just a diagnostic report instance. And we have a mechanism of serializing each resource in one of the three different paradigms. When we started out, we said that we were going to have a formal definition for every element in every resource mapped to the version 3 reference model. We've kind of fallen away from that because we come to the conclusion that nobody cares. And we were spending a fair bit of time and energy creating those mappings, but nobody was looking at them, nobody was reviewing them. And when a few of us spot checked them 5 or 6 years ago, we discovered that many of them were slightly up to lunch and had been for a long time, and it hadn't mattered. So we sort of quit worrying about that. FHIR resources also have built into them the ability to have extensions. So we can have extensions on the resource as a whole. So something like what is your tribal affiliation on patient, but we can also have extensions on individual data elements. So if you have a birth date, you can specify that birth date in a different calendar, or you can specify an extension that says approximate birth date. They were born sometime in the summer between 1930 and 34, because that's what we've got. And yeah, represent that using a formal date structure, but you can throw an extension in that lets you send text. And the other thing is that every single resource has within it a human readable component. That was one of the other things that I mentioned earlier, but forgot to put a slide in here for. One of the lessons that we picked up from CDA was that having human readable text as a fallback is super, super helpful, because when you're sharing computable information between systems and saying, I've got an address, I'm going to break that down into components, I'm going to have a use that says this is a physical address, it's their primary address, it's got a city and a state and a postal code and an address line. That's great. But eventually, as you send data from A to B to C to D to E, there'll be some system in that chain that doesn't recognize maybe all of the core data elements, certainly doesn't recognize all of the extensions. So you're going to have house put across the street from, and the system's going to receive that and go, I don't know what that is. I don't have a place to store it in my system, so I'm going to make it go bye-bye because I've got no place to put it. Also, you have systems that change. So if you have data that was created a year ago or 5 years ago or 20 years ago, your confidence that a system that's reading that today is going to understand all of it is also lower. And so it's helpful to have a fallback of here is a human readable view of all of the important information in that package. So that if I receive an instance and it contains some extensions and I don't know what they mean, I can at least present to a human being, here is the story in human terms for you to consume. And if there was anything important that we weren't able to pick out of the discrete data, it's there for you. And that does a few things for us. It means that when I update my system to start supporting a new data element or a new extension, I don't have to count on all of my communication partners also upgrading at exactly the same time in order for me to safely share data with them. I just put the important stuff that I have also into the narrative, and they will receive my instance. And if they know this new extension, great, they'll display it from that. And if they don't know the new extension, that's okay, because they've got the human readable view and they can say, hey, there were a couple of things that I couldn't extract from this. So here's the human readable view if you want to take a look at it and make sure that there's nothing important there that you need to worry about that's not already taken into account. So what are resources? We've got a whole whack of them. And they range from different types of entities, so patients and practitioners and related persons and organizations. We've got lots of clinical ones. We have allergies, we have medication requests, which is prescriptions and stuff like that. We have goals, we have diagnostic reports, but we also have resources for infrastructure. So we have a resource called structure definition, which we use to define resource and extension and a bunch of other things. We have resources for code systems and value sets. So we actually use FHIR resources to define the FHIR standard itself. And that's really powerful because let's say you are doing clinical research and you have rules around how you're collecting your data. And those rules involve using particular sets of codes from particular code systems. We can create an instance that combines, here is my protocol, and here's the list of codes that I'm going to use and the value sets that are filtering those, and maybe even the profiles on the data that I'm going to be using to store that information. And so we can mix and match structural stuff and clinical stuff together if and when that happens to be useful. All of these resources that we have then connect together. And you can think of the connection mechanism as kind of like a hyperlink. So if you go to a web page, maybe Wikipedia, as you're reading the web page, there will be a little underlined piece of text and you know that if you click on that piece of text, you will get to learn more about this other thing. So you're reading about Martin Luther King, and there's a link to one of the speeches that he gave, or there's a link to information about his assassin, or a link to information about US civil rights or whatever, and you can go from place to place to place. In the FHIR world, I can have a record about a procedure, and it has a hyperlink to the patient. So if I want to know more about who this patient was, what their demographics were, what their contact information is, I can click on follow that link to go see that. I might have a report that was written about the procedure in terms of how did the surgery go, and I can follow the link to go see that. The procedure might have been done because of a particular symptom or a particular diagnosis. The procedure was part of a particular encounter. It had a performer who was a particular practitioner. And so I can chase those links, but I don't have to. The procedure itself, because it has the links within it, is a complete statement. It says this particular patient on this particular date had this type of procedure done for this reason as part of this encounter. Performer was Dr. Smith, and you can find the report over here. That's all embedded within the procedure, and the links, because they are resolvable, I can chase them or not. And every place that we've got a link, we've also got a little bit of text. So instead of just saying, this procedure was done to patient 123, because that's not terribly human friendly, I have a piece of text where I can see instead Mrs. Jones Smith, and possibly even Mrs. Jones Smith, age 57. And similarly, when I'm pointing to the practitioner, I can say Dr. Jones. And the encounter, there isn't necessarily as much of a natural ID there. I might just have the visit number as the business number. Condition, I can certainly have text. There's more detail about every single one of these things because the patient isn't just Mrs. Smith. She has a gender, she has a date of birth, she has phone numbers and next of kin and all those other kinds of things. I don't see all of that in the little bit of text. I just see a little bit of text. And if I want to see more, I go and follow the link to find out that more information. So let's see what a resource actually looks like. So this is the XML representation. Uh, there's a similar representation in JSON. I'll maybe show that to you when we actually go dive into the specification itself. But if you were to take this and if you were to give it to an actual clinician, they wouldn't be happy because there's a whole bunch of funny characters in it, but they could read it. I've got, well, I don't know what this generated stuff, I have no idea what this string is, but Henry 11 the 7th, MRN 123456, male, yeah, that makes sense. Extension, what the heck is this? Something or other to do with trials and renal. I don't really know what that is, but hey, I know what that thing looks like. I could probably put that into a browser and find out what it meant. And you could. If it's been designed properly, you can absolutely take that URL and stick it into a browser and find out what it means. They've got an identifier. I don't know what this is necessarily, but I could put that into a browser and go find out, and it would tell me that MR stands for medical record number. And system, I don't know exactly what that means, but okay, it's something or other from goodhealth.org. It's their set of identifiers. And then I got 1, 2, 3, 4, 5, 6. Okay, so I got a medical record number. I know what that is. I got a family name. I got a given name. I got a suffix. Gender, that makes sense. I've got a birth date. And then I've got this pointer over here to organization 2 with Good Health Clinic. And this is my hyperlink. So in this case, it's not an HTTP colon set of stuff because it lives on the same system as the patient. So I don't need to give the whole way of finding it. If you know where this patient is, the organization is going to live in the same place. And so you can go grab it. If it was living on a different server, then I would have a full HTTP colon / whatever. This is what instances look like in FHIR. And so they are designed to be relatively intuitive, relatively human readable, not so much because we're going to throw them at clinicians, although we may occasionally show clinical people instances as they're helping create real examples and stuff like that, but because we're going to throw them at software developers. And the software developers are going to be talking to clinicians and they're going to be talking to business folks. And it's really, really helpful if the names that the business folks are using and the clinicians are using are relatively well aligned with the names of the data structures actually going over the wire. That means there's a whole lot less mapping and cognitive work that the software developers have to do. And that makes it much more likely that what they produce is actually going to work right. So let's look at the full patient resource. This is the UML diagram representation of the patient resource. And it says it's got a parent of domain resource. We'll maybe talk about that in a bit. But it can have 0 to many identifiers. The data type is identifier. It's got a flag called active. So is this an active record or not? It's got a name. The data type there is human name. By the way, that is not the name for a human. It is a name assigned by a human. So if you have Fluffy in your veterinary system, that is a human name. We don't know exactly what the cat's name is for itself, but we tend not to capture it in computable records because we're trying to share data with other humans, not with other cats. We have telecom, that's where we put the phone number or email address or a website. If you happen to want to capture the website for your patient, you can do that. We have a code for their gender and a pointer to the list of codes for that. We've got a birth date. We have deceased. This deceased has an X beside it because there's actually a choice of data type. You'll either have a deceased Boolean or a deceased date time. You cannot have both. The reason that we don't let you have both is because otherwise we will have systems that will inevitably send deceased equals false. Deceased date time is December 3rd, 2024. And then we look at that data and we go, huh? So we specifically prohibit you from sending both data types when one of them implies the other. So you can either say they are deceased or they're not deceased, or you can say when they died, but you can't send both of those things. We have address, marital status, various other things. We also have some complex structures. So a patient can have 0 to many contacts. Within each contact, we have a relationship and a name and a telecom and stuff. We have a smaller complex structure for communication. So patients can have a language and can have a flag that indicates that that language is preferred, and they can have links. This is a relatively simple data structure. If you look at version 2 of HL7, that standard, there are 2 segments that convey patient information, PID and PD1. And between the 2 of them, they've probably got close to 100 data elements. So this is a much simpler data structure. And again, is focused on that 80% rule. All right, let's go take a look at paradigms briefly. So we have 4 main paradigms. We have REST, we have documents, we have messages, and we have services. REST is the one that is most widely used in the FHIR space and has the most excitement around it because it is simple. If I want to create a patient, the mechanism for doing that in REST is the same in Canada as it is in Nigeria, as it is in Russia, as it is in Argentina. The data structure is the same. The call is the same. The syntax of the URL is the same. There is not really any customizability in terms of how that happens. We use the basic verbs that are defined in the HTTP standard. We have get, we have post, we have put, we have delete, which corresponds to the standard computer science notions of create, read, update, delete that we've had for a long time. There are some variations on those. There is an ability to go grab history or to read a specific historical version or to perform a search or to perform conditional creates and updates and certain other types of things. But it's a very constrained set of things that you're allowed to do. And you're generally performing operations on one resource at a time. Batch and transaction do give you some capability of passing around a whole bunch of things at once, but it's relatively simple operations, and that makes it harder to mess up. And it also means that there's going to be a lot more reusability as you are trying to support implementers in Alberta and BC and Ontario and Quebec, or for that matter, Massachusetts and the UK and elsewhere. You can reuse your RESTful interfaces a whole lot more places. One of the challenges with REST is that it is client driven. So the client decides what's going to be created or read or updated or deleted and in what order. The server can say, no, you don't have permission. But the server can't really say, well, no, you have to create these things in this order, and I want you to do a read before you create this other thing. You can have some level of dependencies innate in the data, but other than that, it's really up to the client how they want to approach doing stuff. And obviously, you need to have a trust relationship to make any of this stuff work. So a RESTful call you're going to have some sort of a URL that is your server. In our slides, all of the servers have the word fire in them, but they don't have to. It could just be https://2.17.384, just a raw IP address. That's all fine. And then we have the resource type, which you're messing around with. And we've got the resource ID, which is the unique key of this record on this particular server. And if I perform a get on that, I will get the current version of patient number 1 on that particular server. The ID might be a number, the ID might be a GUID, the ID might be some random string, it might be a date, it could be various things. It's up to the server to decide what those are. The server assigns those typically. I can also perform a search. So same sort of structure, whatever my server is, the resource that I'm going after, and then a question mark, and whatever my search criteria are. And in this case, rather than retrieving a specific record by primary key, I'm instead going to find the collection of records that happen to have a value that matches that search parameter. So the name search parameter is going to look against given name and family name across the entire collection. And if there's Smith in any of them, then I will get back that record. And I might get back 57 or 280 or 0, depending on how many Smiths happen to be in that system, which is probably driven by where in the world you are. And you're not going after any particular ID. So the complete list of things that you can do with a RESTful interface is summarized on this slide. So you can hit just the base server address, and you can actually query and perform searches against the entire record, or even say, give me all of the data, all of the versions of the data on your system that have changed in the last 5 minutes. And there are systems that will do that to sort of maintain synchronization. You're generally going to be pretty careful about who you allow to invoke that operation because it's expensive. You can also post to that base server. If I want to perform a transaction and I want to create a patient and a bunch of observations and encounter, I can post a transaction bundle to the base URL and perform that. There are other things that I can do at the patient level or at the resource level. Others I do at a specific instance. I can also do certain operations on a particular version of a resource. So I can refer to patient as it was at a particular time point. Not necessarily so important for patient, but maybe more important for something like a condition, where what was initially shoulder pain evolves to become myocardial infarction. Whether that's okay within your organization to evolve the understanding of the condition, or you would delete the old one or refute the old one and create a new one, it may vary, but knowing what version you were looking at when you decided to do something matters, even if it's just a question of this was an active condition as opposed to a refuted condition, or something that they've recovered from. It doesn't make sense to have done the intervention on something that they recovered from. But if you link, when you do that hyperlink, if you point to the specific version, then you know exactly what the story was. Documents, similar to CDA. In fact, you can do CDA on Fire. We've mapped all of these structures in CDA to Fire. In this case, you have a collection of resources. So you've got probably a patient, although documents do not have to be patient-centric. You can have documents about a location or a practitioner, whomever. You might have allergies and care plans and conditions and various other kinds of things. But there's also a special resource that we use for documents called composition. And composition contains the metadata about the documentation process itself. So who created the document, when did they create it, what kind of document is it, and what's the table of contents? What's the order in which somebody should read this? What are the titles of the sections and subsections and subsections? And in this collection of resources, which ones are associated with which particular sections? We package this up into a bundle resource, which is a special resource that lets you collect a whole bunch of other resources together. With a document, you have a single context. So it is all about this particular event, this particular patient, this particular encounter. And key thing with documents is that you can sign them and say, I attest to this whole collection, and it's now frozen together, and I will go look at this collection 20 years from now, and it will tell the same story. So documents are really useful when you want to have a frozen collection of stuff, and when you want to have a particular organization of the data for human presentation. With messages, works the same way as version 2 and version 3 messaging. It's similar to documents in that you also have a collection of resources. The collection is whatever is necessary to satisfy the use case that the message happens to have. And again, we have a special resource at the start. And in this case, it's the message header. And that says who is sending this message, who is supposed to be receiving this message, what is the event that it's communicating, what is the sequence number of this particular message, what's the timestamp of this message, all of that kind of metadata. With messages, you've got a request response behavior, but you can do more complicated things. So I can say, here's a patient and here's another patient, and I want you to squish them together in a merge function. You can't do that easily with REST because in REST, you're doing one thing at a time. You could possibly make it work with transaction, but you're still having to say, here's what the data needs to look like when you're done. Whereas with the message, you can simply say, here's what patient 1 looks like. Here's what patient 2 looks like. I would like you to merge them. Please invoke magic algorithm 1, 2, 3 and figure out what that means. And by the way, while you're at it, go cross-reference all of the data that is associated with those patients and make things right. REST, you would actually have to make separate calls to every single allergy intolerance lab result, whatever, to change their pointers to be to the new surviving patient. Or alternatively, you'd have to do some other kind of magic. Whereas messaging, basically, you can define your magic event code that causes magic things to happen and trust that the server is going to go and do that stuff. Messaging is always event driven, so something happens in the real world that causes a particular message to flow. Messages can be synchronous or asynchronous. So I can fire off a message and I'll get an initial response that says, yeah, got it. But the actual processing may happen over the course of minutes or even over the course of days. Which is something that we generally don't have in the RESTful space. There are mechanisms in REST around bulk data where you can actually send in a collection of 2,500 records and say, please process these. And it'll chug away and you can monitor a particular endpoint to see when it's done. But that's more advanced functionality. And then we have services. And with services, typically it's through invoking operations, and we actually have a slight bias towards using custom operations rather than messaging because they have a little bit less overhead. But with services, you can sort of pass in whatever you like. You can pass in a bundle, you can pass in particular resources, you can pass in just individual data elements, you can pass in any combination of those. Typically, you will still use HTTP, but you don't have to. In fact, you don't have to do that for messaging either. If you wanted to send fire messages over the MLLP protocol that's used in V2, you could do that. In the operation space, if you wanted to package fire up over SOAP, you could. There are people who do that. We look at them a little bit strangely, but the reality is sometimes that's what your infrastructure is set up to do. And if you've already paid for the infrastructure, it may make sense to continue doing that. The only real rule is if you're doing services and you want to call it fire, you have to be using the fire data structures and fire data types. Regardless of what your paradigm is, the content that is being passed around is all going to be fire. So you receive a lab result, you interact with it to put together a discharge summary, and then send off a fire document. In all cases, that patient structure, the observation structure, the diagnostic report structure, the condition structure is going to be the same. You may not, in some cases, you're going to have a bundle of things and you're going to have a message header. In other cases, you'll have a different bundle of things and you'll have a composition that organizes things, but the rest of it is all organized the same way. Fire also has pretty robust support for terminology. So we have a resource to represent code systems, including complex code systems with relationships and hierarchies and multiple designations and properties on all of your codes. We have the ability to define value sets, which are collections of codes. So we can say, I want all of SNOMED, or I only want SNOMED procedures codes with a body site of lung and specify the filters. Oh, and by the way, I also want to draw in the codes other and unknown from the secondary code system. And we can do all of that. We can represent a mapping of one set of terminology to a different set of terminology. So if I want to convert between SNOMED and ICD-10, or between US CPT codes and SNOMED codes, I can create maps to do that, and I can share them and other computers can understand them. So we don't have to only use spreadsheets anymore. We can express all of this in a computable way, including things like this mapping is broader, this mapping is narrower, this mapping is dependent on this other data element. We have naming system, which lets us have a computable representation for identifiers. So I can say this is US Social Security number, or this is Alberta Provincial Health number, or this is the medical record number in hospital XYZ, and computably represent those, which theoretically means that if I have somebody visiting from New South Wales and they show me their driver's license number, I could actually look up and find out what is the official system URL to use for New South Wales driver's license number, even though that's not a type of identifier that I see very often. That becomes possible with naming system. And then when we are defining the standards for sharing data, we'll have a structured definition that contains a bunch of element definitions that will point to value sets and will say, this is the set of codes that you shall use for gender. You are restricted to male, female, other, and unknown as the gender codes. And yes, I understand that there's a whole lot of other considerations around gender. We have a big implementation guide that talks about all of those. And the answer is that for most things, you're not sticking them into the simple demographic gender element. You have extensions that let you convey all kinds of things around identity and what collection of body parts you have and how you identify. And all of those are things that often vary from jurisdiction to jurisdiction in terms of what is relevant and what kinds of things do you want to say. We have the notion of two-spirit here. That doesn't necessarily hold in every other country. And some countries less than they used to, and less than we might wish that they did. And so we have this general mechanism where everywhere you are in the world, here is a set of codes that you can reasonably map to. And then we have this ability to convey other things. And I have my first question, yay, from Anonymous. How can FHIR be extended or integrated with clinical reasoning module to enable temporal reasoning over patient data? So there's lots of answers to that. There's actually a whole set of resources in FHIR that are specifically focused on knowledge representation and clinical decision support. Um, but in terms of how is it most frequently done, there's actually a standard that lives on top of FHIR called CDS hooks, which allows an EHR or any other kind of uh, system that is user facing, as they are doing different things in their workflow, admitting a patient, ordering something, discharging a patient, looking at it, looking up a patient's data, for it to, in the background, fire off an event saying, hey, here's what's going on. I have a user who's ordering stuff, or I have a user who's booking an appointment. Here is the collection of orders. Here's the ID of the patient. Here's my current encounter ID. Do you have anything useful? And oh, by the way, here is an access token that you can use to go and access the rest of their records so you can look up their labs or their conditions or whatever else you need to, that we have negotiated in advance is appropriate for you to access and that I have trust for you to access in this circumstance. All of that has to be in place. And they can go and retrieve whatever they need to decide, do I have anything useful to say? And then they can pass back either small cards that can be made visible to the user, or system actions, which allows things to happen in the background automatically for things like, hey, um, this therapy is contraindicated, or would you like to launch this smart application tool, which will be helpful in this context, or um, this patient is part of this clinical trial, and because you're about to give them this drug, there's this additional questionnaire you need to fill out. Would you like to launch it now? That sort of thing. So that's the most common way of integrating uh, workflow or clinical reasoning directly into clinical workflow, but it's not the only way. There are, I mean, you can use the clinical resources or clinical decision support resources to invoke uh, decision support directly as well. It's just not as commonly done that way because CDS hooks is a mechanism that the AHR vendors have sort of said, this is simple enough for us and is plug and play enough for us that we're happy to use this approach. Whereas some of the more sophisticated things that you can do with the clinical reasoning module, they sort of looked at it and said, yeah, that's really cool. You should do all that stuff and then expose it to us over CDS hooks. So I hope that answered your question. And if not, feel free to follow up. Right, I was talking about bindings. So you can have a required binding. You can also have looser bindings. You can have a binding that says you need to use LOINC, unless there isn't a LOINC, in which case you can send just text or a local code. We can also have example bindings. So here's a set of codes that you could use, but it is totally fine if you choose to use something else. And in fact, there are also circumstances where there might be multiple bindings, where you might say, you have to send a SNOMED code, and you have to send an ICD-10 code. And because we are also dealing with some really old systems, you have to send an ICD-9 code. And here's some concept maps that you can use to help yourself do all of those things. So we have some flexibility in terms of how tightly you need to adhere to the set of codes that are specified. Profiles. The resources that we have are generic. So if we go look, if you remember seeing the patient resource, those of you who are particularly sharp-eyed might have noticed that they were all 0 dot dot something, 0 dot dot 1 or 0 dot dot star. There were no mandatory elements. You don't have to have an identifier on your patient. You don't have to have a gender on your patient. You don't have to have a name on your patient. And in fact, you might have a system that doesn't capture name at all because you're a veterinarian and you treat cows and herds of chickens, and the name of the chicken should you actually be able to keep track of which one that you're spraying at the moment? You don't know, you don't care, it's not relevant. Or you might be in a public health situation where you're doing reporting, which is specifically anonymized, and you don't want names. In the version 2 world, the solution was, well, you have to have a name, so we'll just stick in a fake one of John Doe or Jane Doe, as the case may be. But that creates all sorts of problems because occasionally that propagates through into real data, and you think that you've got an actual name, and you print a wristband or something, and then you don't really want that. Or you have a patient whose name actually is John Doe, and then everybody is super confused. So in FHIR, you simply would omit the name because that's a legal thing to do. But when you're operating in a specific environment, you might want to be tighter than that. You might want to say, well, in our patient registry, we're not going to have any patients that don't have names. And we will tolerate patients that don't have dates of birth, but there has to be a reason specified for why it's missing. And furthermore, we have a rule that says that if the patient is deceased, then it can't be an active patient record anymore. So we have a co-occurrence constraint. And so we need to be able to specify these rules that apply only in a certain circumstance. And profiles allow us to do that and allow us to do it computably. So some of you may have seen CDA specifications where you got basically a PDF document with a whole lot of shells and shoulds. That tends to make people's brains go to mush as they read them and doesn't really help you very much in terms of doing computable validation. So what we do is we use the same infrastructure that we use for defining the resources, and we can tighten up the rules. We can constrain the cardinality, we can constrain values and say that in this particular context, this value must have the specific fixed value. We can constrain the terminology and say in our space, we don't have males because we're a type of clinic that doesn't deal with those. We can constrain out certain elements. We can say, in our world, deceased is not allowed because we don't allow you to book appointments for deceased patients. And capture all of that in a computable form and share that in a computable form. We also have capability statements. Capability statements allow you to say what it is that a system actually does. So my system supports search and read and create on allergy intolerance, supports search and read, but not create on patient, because that's handled through a back-end process. And you can go through all of the different resources and specify what it is that you do. You can also specify what documents you produce or consume, what messages you can send or receive, what operations you either invoke or can have invoked on you. And one of the key things about FHIR is if you want to say I am FHIR conformant, the only time that's a meaningful statement is if you actually have a capability statement that says, and here is what I do. So if you ever run into a system that says, yeah, I'm FHIR conformant, and you say, great, can I have your capability statement? And they look at you and go, huh? Then you're talking to a marketing person who actually doesn't understand FHIR, and you may be dealing with a system that isn't actually FHIR conformant. Because if you have conformance to FHIR, then you need to have the capability statement. If you're a server, there's actually a specific API call that you can make to retrieve the capability statement, and it darn well better reflect what you do. If you're a client, there isn't really a way to go and ask you, because as a client, you go and do the asking. People can't ask you stuff, but it's still something that needs to be available that you could at least communicate if a human being asked you to. So FHIR specification itself is available at hl7.org/FHIR. It is a web-based specification. You can navigate it. It's jump all over to see what it is that you're interested in seeing. If I don't get questions, we'll spend take a little bit of time to do that, but we won't do that right now. In terms of where we are in the fire development life cycle, we started way back in 2011. We have had a number of releases. We have draft standard for trial use or standard for trial use. It's the same thing, we just changed the name. And we finally started to have some normative content with R4. That was published in late 2019. Then we had R4B, and then we had R5. Reality is most systems are still on R4. We are currently in the lead up to producing R6, which will actually make most things normative. There'll be some stuff that some resources that are going to get pushed out into implementation guides, but the bulk of the clinical resources that are of interest will be locked down, meaning we will not make breaking changes to them once R6 is out the door and approved. Fire is a global specification. This is a little bit old, but the gist of it is largely the same. There's actually more and larger dots happening in Africa now. There's a bunch more stuff happening there. But as you can see, Europe, North America, South America, Asia, fire is very much global in its scope. Last thing I want to leave you with is, if you are going to be doing stuff in the fire space, the most important link for you to know, aside from the fire core spec, which is hl7.org/fire, is chat.fire.org. That is where the community hangs out. We've got almost 30,000 active members, and almost every question that you could imagine asking has probably been asked there by somebody. And if not, feel free to throw in your new question. And you will find people who are happy to answer. Or occasionally we'll say, that's an excellent question. We had not thought about that before. Can you create a tracker item? And we'll give you some instructions on how to create a Jira issue that will cause us to go and update the specification with an answer once we figured it out. But it's a welcoming community, and I would, even if you think you know what you're doing, it's always good to double check, and there's always people who are happy to give their thoughts on your particular architecture, your solution, your approach, and getting those answers will inevitably make your solution better.